Hi guys, in this video I'll talk about non-inertial frames and pseudo force, how it can be applied, what are the benefits. So let's get started. When observations, basically observation of acceleration, are taken from an accelerated frame, which is also called non-inertial frame. Accelerated frame is called non-inertial frame. When the observations are taken from that accelerated frame, then to apply Newton's laws, we need to apply an external additional, which is non-real force called pseudo force in addition to all the real forces. Okay, so the crux is whenever observations are taken from an accelerated frame, you have to apply pseudo force in addition to all the real forces. What is the magnitude of pseudo force? Is mass of the object which is observed, like mass of the block, mass of the car, or mass of the person who is being observed. Okay, who is being observed, and acceleration of the frame from which observations are taken. Okay, from which observations are taken. Direction of pseudo force is opposite to the direction of acceleration of frame of reference. Okay, let's say reference frame is moving upward, so the pseudo force applied by it will be in downward direction. Okay, then by application of pseudo force, no change takes place in any real force. Okay, there is no change in any real force by application of pseudo force. They remain same as it is. Okay, so there are now two ways of solving a question from inertial frame, from which we need not to apply any pseudo force, and another is from a non-inertial frame, from which we need to apply pseudo forces. But one thing is to be remembered, that when you are observing or when you are applying pseudo forces, then the observations should be taken from the accelerated frame. Okay, let's start with the first example to make it more clear. There are two observers, 1 and 2. One is moving in a lift in which a block is placed, and there is another observer which is standing on the ground, observer 2. So let's start with how observer 2 will look at the block. Observer 2, O2. He'll see a normal reaction from the floor and an mg, and he'll see that block is accelerating in upward direction as this. So he'll write the equation n minus mg is equal to ma, and for that n will come out to be mg plus a. Okay, as O2 is a inertial observer, or we can say non-accelerating observer, he will not apply any pseudo force. But when the same observations or similar observations are taken from by observer 1, which is accelerating, he'll say that there's a normal reaction, there's a weight of the block, and there's an additional force. As the acceleration of observer 1 is upward, so he'll apply a pseudo force in downward direction, which is equal to mass into acceleration of the observer itself, which is a. And he'll say acceleration of block with respect to 1 is 0. He'll say that block is not accelerating with respect to me, so its acceleration is 0. Again, this is the acceleration with respect to observer, should be measured from the accelerated frame itself. So how he'll write the equation? He'll say n balances, or n minus mg minus ma is 0. Same answer will come out, n is equal to mg plus a, and here also n is equal to mg plus a. Okay, very slight changes are there in the equation. You write ma on the right side of equal sign, and you write minus ma on the left side of equal sign. Okay, so basically the equations are also same whether you solve it from ground frame or in an accelerated frame. Okay, so let's move on to the next example. In the next example, a room is accelerating with an acceleration a in which a pendulum is hanging. Obviously, the pendulum will hang by making some angle with the vertical in the backward direction. There are again two observers. One is in the frame of the pendulum and another which is standing on the ground. For observer 2, which is an inertial observer, again no pseudo force will be applied. He will say that there are only two forces, one is T, another is mg, and the block is accelerating in horizontal direction, or Bob is accelerating in horizontal direction. So he'll say that T cos theta balances mg and T sin theta provides acceleration. And from that we can always calculate tan theta as by dividing these equation, MA, this is MA not G. Tan theta is sin theta by cos theta is A by G. So this is how we can get up to this result. Now let's see how observer 1 will explain this. Observer 1 knows that he is an accelerated observer whose acceleration is A. So in addition to these two forces, he will apply another force which is a pseudo force. Mass into acceleration of the observer 1, which is A itself. And he'll say that acceleration of stone or acceleration of particle with respect to observer 1 is 0, because it is at rest with respect to observer 1. So he'll say that these things are in equilibrium, and he'll divide this as T cos theta and this as T sin theta. Again write down the same equation, T cos theta balances mg, and or say T sin theta minus ma equal to 0. Again by taking to this side we get T sin theta equal to ma, and similarly again we get tan theta as A by G. Okay, so it is just how you take the acceleration and just convert it to pseudo force in another diagram when you are taking observation from an accelerated frame. Let's take the third example. Find acceleration of the wedge so that block remain at rest with respect to the wedge. Okay, I can again solve this from both the frames. Let's solve first of all from the ground frame. Again, acceleration of wedge, acceleration of block with respect to wedge is 0. It implies acceleration of wedge is same as acceleration of block, which is A horizontally. Okay, so now drawing this, we can say FBD of this block. This is a real force N from the ground, from the wedge, and this is mg. Again these two forces provide this acceleration which is horizontal, and this angle in theta. Again I can say that N cos theta minus mg balances itself, and the remaining force N sin theta, this is N sin theta, will give you the required acceleration ma. So again N cos theta equal to mg, N sin theta equal to ma, so tan theta is nothing but A by G. These two are similar expressions, just tension is replaced by normal reaction. And in the next, when I just place an observer here which will move with an acceleration A with wedge itself, so what he do, he'll draw the FBD like this. He'll say that there's a real force N, another real force mg, which will act downward, and he knows himself that he is accelerating, so he's a non-inertial observer, so he'll apply a pseudo force opposite to its acceleration, which is ma, mass of the object, acceleration of itself. Though in these cases I am taking acceleration of the object and the acceleration of the observer to be same, but they might be different. So A will be the acceleration of the observer. Okay, so and acceleration of block with respect to observer will be 0. So we'll say that the block is in equilibrium, and just resolve the forces. N cos theta will balance mg and n sin theta will balance ma. So we'll write n sin theta balances ma, n cos theta balances mg, and divide these two equations to get tan theta equal to a by g. Okay, again the most important concepts are shown. Repeat these questions at least thrice. Enjoy.